Alright, so for standard 16 we have compare and contrast the 1D gradient, divergence, and curl versions of the fundamental theorem of calculus. So here we have the 1D version, which is the integral from a to b of df dx equals f of b minus f of a. The gradient is the integral of vector a to vector b of the gradient of f times dr equals f of b minus f of a, those being vectors. Then the divergence, which is the integral of the divergence of v dv equals the integral of v dot dA, and then the curl dA equals the integral of v dot dl, that being Stokes and that being Gauss's. So here are some differences and alikenesses. So 1 and 2 only depend on the endpoints. So from A to B, it could go anywhere in between, but it doesn't matter because only the starting and endpoints matter. 3 and 4, though, depend on the entire path, so where it goes throughout. So it doesn't matter where it starts and ends, or I guess those still matter, but what happens in between matters as well. 1 obviously is 1D. 2 works for 2D. 3 and 4 are both 3D. So vector versus scalar. 1 doesn't involve either vectors or scalars. 2, the gradient starts as a scalar field and goes to a vector field. 3, divergence is the opposite, so it starts as a vector field and goes to a scalar field. And then curl involves all vector fields. The v is a vector field and f is a scalar function, so in here we can see the f is up here in the gradient, so f right there is a scalar function, and then v is in these ones and is the vector field. So for the d parts of them, dx is the position, obviously, x, that's from the 1D. From the second one, gradient, dr involves the vectors a and b, and it's like the position of the vectors, I think. And then 3 dv is the volume, dA is the area. There's also a dA in the next one, so the area includes x, y, and z, and then dl, with L being the surface.